So we're going to do a conductivity test. When these touch, that means when there's a direct connection, this beeps. So we're going to go like that. There's a direct connection. That's channel A. We'll check to see if there are any breaches because of the water. So nothing beeping. So channel A is working. Channel B is working just fine. Checking over to channel A, nothing. So perfect. So that's two independent channels. They're both isolated from each other, even though this is submerged in the water. And this is just a POE mini. Right inside some tap water. And again, what we're going to try to do here is view if any kind of effects happen when we start powering this coil. So this is the setup already running. We have a frequency of 9.12 kilohertz. We're running at 76 watts. It's from the wall, from the amplifier. So the amplifier is flowing into the coil, submerged in water, and that's flowing into this 4,000 volt xenon bulb sold at Radio Shack. It's rated for 4,000 volts, 300 volts on the cathode. And this is wireless electricity. So because I'm getting close to this coil, it's able to turn on this LED full intensity. And you can see how intense that is. So again, we're using 76 watts. I'm sure we could do a lot more with this energy right here. And the benefit that we're seeing from submerging the coil inside the water like that is now we're not getting any kind of ozone production. So it's safe to work with now. Now the only thing that we made an observation of that's not safe is when we switch this to radio waves. If we get really close to the coil, you see that those radio waves spike up. So at this particular frequency, it's not best to engage much with this coil. And the magnetic field, so I just switched it to magnetic field, and we'll go ahead and check this out. So I'm backed up about 6 feet, and now around 6 feet, that's where I just start losing some of that magnetic field. This will extend out another 4 or 5 feet. So it's a really large magnetic field. So this is the coil now with the output ends closed. So we went ahead and took off the 4,000 volt bulb, and we're just pulsing it like a speaker. So we're going to go ahead and turn on the frequency. That's 27 hertz. So I went ahead and I put a glass bowl inside of this bowl because you don't want to have the magnet rubbing on the copper coil. It'll scrape off the enamel and then it'll short out the circuit. So right now it's properly wired. So we can have a blender that produces power. So it's only making those wide progressions like that because it can't find a way to stay right in the middle. So if I change this bowl it'll be able to rotate and create a better vortex effect. So I'll raise up the frequency. That's 27 hertz. It's pulling 183 watts. I'm raising up the frequency. We're already at 60 hertz. 70. I'll just go ahead and hold it now. 71. That's 80. That's 90. 90 hertz. Hertz, 149 watts. Check out the voltage spikes now that we're spinning at higher RPMs. So our blender is producing more power now. Still spinning even though I'm lighting up this LED, and this LED is looking like it wants to pop now. It's a very bright LED there. I'll raise it up a little bit more. That's 90 so far. As we get it up to 100. That's 100 hertz. So we should be producing even more of a spike now. That's a lot of power for a blender. Let's go a little faster. That's 110 hertz. We're at 122. So we're getting a response at around an inch away. When I get real close, it's almost going to pop this LED. That's a 3.4 volt LED. That magnet is spinning pretty fast in there. Making some interesting noises. That's 127. Very interesting noises. A lot lot of power there. That LED cannot take much more. So that's 145, and this is producing a lot of power now on this LED. Pretty intense. 145, I've never seen this before. That's a lot of power, and that's a strange noise. 145 hertz. This is 149 hertz. Still going. 149 hertz in there. And I just stopped it there because I'm not sure if that's just going to fly out through that glass right now, but it's pretty interesting. Thanks for watching.